organized by the Department of Physics, Cochin University of Science and Technology. To start with, I invite Dr. Srivastava V, Assistant Professor, Department of Physics, to welcome the gathering.
Good afternoon. So as you know, 2025, the year 2025 is proclaimed as the International Year of Quantum Sciences and Technology by the United Nations. The proclamation was in 2024. And according to the proclamation, it will be observed through activities at all levels aimed at increasing public awareness of the importance of quantum science and applications. So Department of Physics in this occasion is starting a year-long activities based on quantum sciences and technology, and we have gathered here for the inauguration of that. And we have a very apt personality for inaugurating that, Professor Dinesh Srivastava, whom you have been hearing for the past 2 days, 2 lectures. So with that opening remarks, let me enter to my formal duty. I would be once again happy to welcome Professor Dinesh Srivastava to Department of Physics and especially to this inauguration. I'm sure that you are already familiar with Professor Dinesh Srivastava attendees. I also welcome Professor S.M. Sunoj, Dean, Faculty of Science, member syndicate, who has been a well-wisher to the Department of Physics, a friend to the department. Welcome, sir. I also welcome Professor Ramesh Babu, Emeritus Professor, Department of Physics, who will be felicitating this function. Dr. Aldrin Anthony, Head of the Department of Physics. Welcome you, sir, to this function. And also I welcome Ryan Kumar, who he is busy organizing this one, running around. I hope he is here. Where is he? So I welcome him also in the name of formality. So welcome you all. We look forward to the year-long celebrations and today to the lecture by Professor Srivastava. Welcome you all.
Thank you, sir. May I invite Dr. Aldrin Anthony, Head of the Department of Physics, to deliver the presidential address.
Good afternoon all, and respected chief guest, Dr. Srivastava, then our member of syndicate and Dean of Faculty of Science, Dr. Sunoj, and Professor Ramesh Babu, and dear faculty, Dr. Sachdevan and Dr. Ryan, who is missing always, and he's running behind, maybe trying to looking into the camera. Yeah, he's here. But Ryan, and faculty member Dr. Titus sir, Dr. Shaji sir, Dr. Nambishan sir, and I have been meeting him after maybe a 2.5 decade. And dear students, dear research scholars, so this is the marking or the starting of International Year of Quantum Science and Technology. I think around the world today is being initiated, or it will be proclaimed as the International Year, though it has been suggested in 2024 itself. So in France, in Brazil, also in Canada and many places, there are different days in some countries. I think in Canada in 2007 or January next month or something. So different places at different days, but UNESCO is actually proclaiming this today as a International Year of Quantum Science and Technology. So when I look back, I think in the last month when I was looking through some of my old bundles of books, I came across a file of 100 years of quantum science, and it was 100 years of quantum science. And so that was a period we were also thinking about starting this 100 years of quantum science and technology, a talk series and activities. So the Department of Physics, and it was a file which were written 100 years of quantum science in 2000. So that time I was a PhD student here. So Cochin University of or Department of Physics, Cochin University was always a front runner in organizing all these type of events. So that's after the Planck's law, maybe 100 years of Planck's law, that may be treated as 100 years of quantum mechanics, and it was celebrated here in the Department of Physics in 2000. So there is no surprise that Department of Physics again is celebrating 100 years of quantum science and technology, which is actually an advanced form of quantum science, which have been applied into different applications in different parts of life. So if you look into this quantum science, and this is being applied into different fields, for example, health and well-being. It's been used for different types of imaging principles and also some medical diagnosis. So different types of quantum dots and different types of imaging systems are there. So this is going to be like what is expected that in the next 1 decade, the world is going to dramatically change the way in which we are looking at. And the major contribution of in the technological innovations is going to be by the quantum science and technology. So this will be there in different fields, for it will be in health and well-being, and also in different things. For example, different type of sensors are going to be made. It's like in magnetometers and atomic clocks. You could see that even in the last launching of the satellites, there was also an atomic clock. So what is the importance here? So for example, yeah, I'll come to that. So there is a quantum materials, which has been which is going to be a playmaker in the next one decade. Seems to be like superconductors, and there are applications of novel semiconductor-based quantum dots and topological materials, which is getting a lot of attention recently. And eventually there is a more attraction is on single photon, single electron detectors and sources, which can be used for different type of applications. So, and entangled photons, that is entangled photons is another concept that which is being used into a reality. I think in 2024 there were a lot of papers on quantum entanglement was reported. So the Indian government has also considers this quantum thing is one of the prime area to invest, and they have decided in 2023 initiated National Quantum Mission. And the government has set apart 6,000 crores rupees for the quantum mission in terms of different research activities and also for different things. And one of them is the prime thing what they were looking at is, I think even before 2023, I was in a conference in Mumbai, and it was and then a representative from PMO's office came there, and he was there only specially. He came in the morning and then just dashed in, and he was asking, we need to build a quantum computer. How much it will cost? We are ready to pay, but you have to give the computer in 6 months' time. And I am from PMO's office, you have to give. Some IAS person, who doesn't know how a technology is translated into a product, was asking the scientists coming from different parts of the country, asking to build a quantum computer in a matter of 6 months. Okay, whatever be. So, but currently the government is focusing at building at least a medium level of quantum computer, even though the Google and IBM, they already have made quantum computers. So they are looking at building a quantum computers of nearly like 50 to 150 qubits. So this is something the government is looking at. So 52,000 physical qubits they are looking at to make a quantum computer. So a lot of activities government is planned, and especially on 4 different areas. One is a quantum computing. So different people are different, and it has been regional wise, it will be divided into different activities. One is the 4 thematic hubs have been formed by the Indian government, and one is a quantum computing, other is a quantum communication, third is quantum sensing and metrology, and the fourth is quantum materials. And how this quantum sensing and metrology, it's expected that nowadays we have erratic monsoon, for example, and the weather patterns are not able to be predicted exactly. So they are expecting that with a new sensors based on quantum science, and it will help us and also with the quantum communication. That's Indian government is also forcing like 2,000 kilometers communication using a quantum communication with the satellites. And with this new interventions of quantum communication and quantum technology, with the new innovations of sensors and quantum computing, we will be able to have more accurate predictions of this type of chaotic monsoons or weather conditions. So this is one of the important things the government is looking at, because the climate change has played a critical role, and all around the world, and the quantum science and technology is believed to be supporting the mankind for a better tackling of this climate change. So with this, I'm just concluding, and so we are from physics background, all of us, and this is an area which was started like 100 years back, and it is good to remember our, how it came, the theories, and our Department of Physics is planning to have a series of talks, mostly like every month. Actually, we had a discussion with the Vice Chancellors to initiate this program in institute level with the cooperation of different departments to have as a single committee or it's a single organization for the 1 year, one complete year, full year for the quantum science and technology. Maybe our dean may be taking some initiative. I hope our university vice chancellor itself, was very happy to do that, but I think we have to take it into the next level, and different department, computer science, electronics, and physics, or all departments should contribute to this 100 years of celebrations of quantum science and technology. And with that, I conclude. Thank you all.
Thank you, sir. Now let me invite Professor Dinesh K. Srivastava, INSA Senior Scientist, National Institute of Advanced Studies, Bangalore, to inaugurate the session.
So, good afternoon, ladies and gentlemen. Professor Sunoj, Professor Antony, Ramesh Babu, good old friend. I'm friend from old time, not old. Professor Sasidevan, and I come all the way to meet Professor Nammi-san, whom I used to meet in SINP almost every day till 5-6 years ago. So thank you very much for organizing this. I will make 2 or 3 small points and then bore you with a longer lecture. You see, one of the most important contributions to confirmation of quantum mechanics was made by the Raman effect. Many things were known, many things had been seen, but the specific levels were seen only after specific levels of molecules and atoms were seen only after Raman effect. And that was one of the most precise confirmations of quantum mechanics. All of you know S.N. Bose's contribution for Bose-Einstein statistics. What is not very well known is that he was teaching in MSc class and trying to derive Planck's formula, Planck's law. And then in the class he made this assumption, what would happen, let us see what would happen if all the particles are indistinguishable. And he derived his statistics, another quantum mechanical phenomena. You all know about Compton effect, right? All of you know about Compton effect, scattering of photons with electrons. Meghnad Saha, working long earlier, discovered the radiation pressure, because of which the sunlight falling on the tailwind of, what do you call it, the comets, ensure that their tails are away, pointing away from the sun. That was actually Compton effect. Only if he had access to a larger group of people with whom he could talk. He could have even formulated Compton effect. Then Bhiva Chaudhary, whose picture is there right in your corridor, she was just a PhD student. And they started exposing emulsions, photographic emulsions in the hills of Darjeeling. They developed it and they found a particle which they had not seen before. It had a mass, they estimated that its mass was about 200 times mass of the electron. And at that, but they had a little problem, the plate was too thin and therefore the particle was not stopping fully in it. So they could only say that its mass should be around 200 times mass of the electron. That emulsion, photographic emulsion plate, thicker ones, were not to be sold to Indians because Second World War was going on. Once the war was over, C.F. Powell in England used the same method, but he had thicker emulsion plates in which the particles stopped. And he discovered what is known as pion and even got Nobel Prize. So you see, we have already heard about quantum entanglement. I'll tell you of one small problem, one simple observation. In the morning you heard about positron annihilation, right? Positron annihilation is a wonderful technique which is being used in what is known as PET imaging. You insert any positron source, but tie it to a chemical which accumulates in different parts of the body, especially if it is cancerous. And if that part of the body is cancerous, it goes and sits there. It emits positron. These positrons are annihilated by photons, by electrons, and give out two photons, which go back to back. And then people can measure these two photons, their time of arrival, etc., and exactly locate the place from where they originated, where the cancerous cells are accumulated. And it is used, this PET scanning is called PET scanning, and is used for cancer treatment. Now what has quantum entanglement got to do with it? These two photons, back-to-back photons, will come with spins like that, okay, anti-parallel. And these two spins are entangled. These two photons which come out are entangled. But even if they get scattered and their directions change a little bit, their spins remain the same way. And if you can also measure the spin, the signal to background ratio, the signal of PET imaging can be improved considerably. This is being done in a friend of ours, Rudra Palit at TIFR. So see, quantum, we missed the industrial revolution. And what was the result? The British, the Europeans, they came and colonized entire Asia and Africa and China and Southeast Asia. And all suffered. We are now out of it. We should not miss quantum revolution. We have not missed the computer revolution, and we are seeing the effect. You know how much, what is the export of IT industry? $320 billion every year. What is the import bill of India for petrol and diesel? $150 billion. So the IT industry is completely shielding India from all these fluctuations in world market in petrol industry. People do not realize this, and they make fun of our IT boys as IT coolies. Don't go by that. You know what they are doing. We should not miss quantum revolution, which is going to completely change the way we have been looking at world, we have been dealing with problems, we have been dealing with all these things. But Now that I have gotten a chance, I would like to tell you that one small thing. All of you have mobiles. All your auto walas and taxi walas are using GPS system, right? You just put a location, share my location. Just a few minutes ago, Ms. Parvati shared her some location with my wife. It is possible because of GPS. Now, how does GPS use modern science? It uses two, special theory of relativity, general theory of relativity, and communication, wireless communication, which is also a quantum mechanical phenomena. Because these satellites which are moving in the sky, they are moving very far away and they are moving at a very high speed. They experience lower gravity, and because of their speed, the time slows down. It is very small because they have moved only with velocity of something like 24,000 or 40,000 kilometers. But the effect is about 41 milliseconds in one day, the delay. And that delay has to be taken care of in trying to locate your position. So quantum mechanics, relativity, general relativity, all the esoteric, beautiful phenomena which were confined to textbooks are now part of your everyday life. And let us wake up, remember, you people are very lucky. You will live in a much better world than we are. Quantum computing, about which Professor Aldrin told, is going to let you solve problems, certain problems in seconds, which would have taken tens or hundreds of years. The biggest breakthrough is going to be in drug discovery, because there are 10 to the power 60 or 10 to the power 80 simple molecules which can be combined. And quantum computing will tell you almost immediately, very quickly, which of them could be useful. So there is no wonder that we are celebrating this beautiful effect. Thank you and enjoy your rest of the evening.
Thank you, sir. As a token of appreciation, we would like to present a memento to Professor Dinesh K. Srivastava. I request Dr. Aldrin Anthony, Head of the Department, to present a memento to Professor Dinesh K. Srivastava. Now let me invite Professor S.M. Sunoj, Dean of Faculty of Science and Syndicate Member of Cochin University of Science and Technology, to speak a few words.
Respected Professor Dinesh K. Srivastava, Dr. Aldrin Anthony, HOD and the President of this function, Professor Ramesh Babu, Dr. Ryan and other dignitaries, eminent scientists, distinguished guests, research students and dear students. It is truly an honor and privilege for me to attend this inauguration of the International Year of Quantum Science and Technology celebrations as part of the Research Training School in Physics organized by the Department of Physics, Cochin University of Science and Technology. As the Dean of Science, I am proud to say that Department of Physics is one of the very active and leading departments in the university. As mentioned by Professor Aldrin Anthony, Department of Physics is organizing different activities or different programs, and I think this is one of the flagship program of the department that connects the department with the young minds or young students or young, the master students who are pursuing for physics as their masters. So, as a non-physicist, to me, this particular topic, this quantum science and technology, is a transforming or fascinating field of science, and that has been attracted by many scientists around the world. I think quantum research is now carried out by many universities, government labs, and companies in different countries. Quantum technologies promise to ramp up innovation across sectors like healthcare, finance, and industry, while helping to tackle global challenges such as climate change and food security. I think Professor Aldrin has explained or touched almost all the areas of quantum science and technology. I'm sure this celebration marks a significant milestone, bringing together young minds, aspiring physicists, and distinguished mentors to engage with some of the most profound ideas in modern physics, quantum science and technology. So I take this opportunity to extend my heartfelt congratulations to the Department of Physics, CUSAT, for their visionary leadership in organizing this event. And initiatives like this is not only empower students with the latest advancement in physics, but also inspire them to contribute to the scientific community in meaningful ways. So may this celebration of quantum science and technology lead to new insights, pioneering research, and future shaped by scientific excellence. So wishing all a productive and enriching experience. Thank you.
Thank you, sir. Now may I invite Professor Ramesh Babuti, Emeritus Professor, Department of Physics, to speak a few words.
Respected Chief Guest, Professor Dinesh K. Srivastava, my dear colleagues, there are other invited guests in the audience, my dear students. In fact, I forgot, good afternoon. It is supposed to be stated before this thing, okay? There is always a sequence in physics. But if you go to relativity, there is no past and present, you know. You can interchange, I believe. Anyway, I'll be very brief. As you said, I'll repeat some of the things already stated by other speakers in, okay. The only problem is, some of the thing I want to say is already been stated. So my job is became a little bit simpler, all right? Anyway, 2025 is the International Year of Quantum Science and Technology, right? So it starts from July today, and it ends at Wednesday, February 2025. And it is, this international year is declared by UNESCO headquarters in Paris. Let me come to some of the things mentioned by our head of the department, Dr. Aldrin Anthony. One of them is, if you look at what are the things you are dealing, or what are the areas you are going to concentrate during this period. If you look at it, I stated health and well-being, industry and infrastructure, economic growth, climate action, clean energy, right? What he said is right. You know, if you look at this thing, you know, any department in this university can have this function today, inaugural function. So I think our head of the department is very clever in the sense that, you know, he did it for the, you take initiative to do it for the first time, all right, in that sequence. Another aspect is, to some way, you know, in fact, I was given this chance saying that it took 2 courses in quantum mechanics. But that is not the thing what is seeing here. It's completely different, all right? So, that's all right. So, the aspect of quantum physics is reflecting in every aspect of what is going around in this world, all right? There are different ways of looking at it. One is, if you think about importance of quantum mechanics and you want to look at it from the next 100 years, to some extent it was there, all right? It is not that, you know, it suddenly came into your, our life, all right? Whether, if you think of solid, what is that, semiconductor physics or whatever, advancement in technology has an element of quantum thing there, but no, that was not very explicit to common man. So I assume that this is a venue where you can educate our common person that quantum mechanics is an important aspect in future, right? In fact, what I am going to do is, I'm coming from Bengaluru Gama Panchayat. Probably they don't know, you know, this quantum mechanics exists. So first let me try to apply this thing to the neighboring people around my house, all right? So maybe that's what I want to say. Because it's basically the awareness of this thing, all right? Yes, Professor Dinesh Srivastava said, if I want, I can repeat some of the intricate aspects of quantum description, right? Can start from entanglement, that thing, this thing, Zeno effect, but whatever not, right? Even your concept of measurement is going to a different level, right? The impact of quantum physics in philosophy, that is another aspect, right? I did not see that thing here, probably it is coming along with some of them. Oh, the role of quantum principle in the study of living things, all right? See, there are 2 ways you can think of living things, you know. Living things are system with large number of degrees of freedom, so there are complications, right, because of the number of degrees of freedom. But there is another aspect which is basically intrinsic in quantum description, right, which is what is called coherent effect. So that type of thing may be important in the study of formation of life also, all right? I think with that thing I want to stop. Thank you very much.
Thank you, sir. Let me invite Dr. Kumar AK, convener of RTSP 2025 and Assistant Professor at Department of Physics, CUSAT, to deliver the vote of thanks.
Good evening to all. Our esteemed Chief Guest, Professor Dinesh Srivastava, INSA Senior Scientist from National Institute of Science Advanced Studies in Bengaluru. The President of today's function, the Head of the Department, Dr. Aldrin Anthony, invited a guest, and the Professor Sunoj SM, the Dean, Faculty of Science, Cochin University of Science and Technology, Professor Ramesh Babuti, Emeritus Professor, Cochin University, Department of Physics, Cochin University of Science and Technology, and invited guests and students, dear colleagues and students. So, it's my turn to deliver the vote of thanks. First and foremost, I would like to express our heartfelt gratitude to Professor Dinesh K. Srivastava for accepting our invitation and being present here today, sir. Thank you, sir. I also extend our sincere thanks to our invited guest, Professor S.M. Sunoj, Dean, Faculty of Science, Cochin University of Science and Technology. Yeah, so sir is busy with some other meeting, that's why Professor Sunoj is not here. So I extend our thanks to Professor Ramesh Babu T, who is an emeritus professor in our department. So he has been working in our department for more than around 35 years. 30 years. So the person who brought Fermi Lab project to Department of Physics, CUSAT, and he has working behind he was the person behind establishing a center for particle physics in our department. So I extend a warm thanks to Professor Ramesh Babu. Thank you, sir. So I also extend a special thanks to our invited guest, Professor P.M.G. Nambishan, a senior professor retired from Saha Institute of Nuclear Physics, Kolkata. Professor Titus K. Matthew, our former head, Department of Physics, CUSAT, Dr. Shaji, and all other colleagues and dear students and participants of this program for attending this function. Additionally, I would like to express our sincere thanks to our research scholars in theory division for making all type of arrangements behind arrangements for this program. So once again, on behalf of Department of Physics, so I would like to thank each and everyone for participating in this program and making it a successful event. So just after this, we will directly go to the public lecture. Thank you.
Thank you, sir. So now we have Professor Dinesh K. Srivastava to speak on climate change and energy options for a sustainable future. I invite Professor Dinesh K. Srivastava to deliver his lecture.
Okay. Good. Half of the students have evaporated away. It's good. Huh? 2 years ago, there were sudden extreme floods in Kerala, leading to large-scale destruction death and misery. It was not because of some installations, star constellations. It was because of climate change. Remember that any time you start doubting that climate change and global warming are fake, which a certain president of a certain country is trying to tell you. This is the only home. This is a picture of Earth taken from the moon. This is the only home we have, mankind has. Forget about all those stories about traveling to Mars and establishing a colony. Even if that becomes possible, there will be 10, 20, 100 people. We are 8 billion people on this earth. There is no planet in living this area where you can reach in one lifetime. All 8 billion people can move. So this is the only home we have. And it is in serious trouble due to global warming, which is causing climate change. But before that, let me just remind you what is a sustainable development. A sustainable development meets the needs of present without compromising the ability of future generations to meet their own needs. During the lecture, we shall discuss signs of disasters which have already started and some technological challenges we face in handling these, where you, people who are going to join the workforce, can contribute. Let us also not forget that India is one of the fastest growing economies of the world. India is now the most populous country in the world with a rapidly expanding population. Our population is continuing to rise. We need to face dual challenge of meeting rising energy consumption. Remember this energy consumption while reducing carbon emissions. And these two things can be difficult to achieve simultaneously, as we shall see. So these are sustainable development goals decided by United Nations, and we shall only be talking about energy. There is a thing called Human Development Index. It is a measure of your education, your longevity, and your income or prosperity. It is so defined that when it is closer to 0, you have a miserable life. And it is closer to 1, you have a heavenly life. India's development index is something like 0.8, 0.6. Most of the Western countries have a development HDI of 0.9. That is why so many people from all over the world brave all kinds of difficulties and illegal means try to go to West. This is Human Development Index is a function of annual electricity used in kilowatt hours per person. India's energy use is about 1181 kilowatt hours per person per year. Whereas in order to achieve something like 0.8 HDI, you need a factor of 4 energy. So we have to rapidly increase energy consumption in the country. Energy consumption will be needed for industries, for people's living standards. Actually, in coming to by 2050 or so, you will need something like 6 to 8 times that much. Now let us remind you signs of global warming, which is actually a atlas of human suffering. Temperatures are rising worldwide as greenhouse gases trap more heat in the atmosphere. The springs are arriving early, the summers are longer and much more fiercer. Droughts and floods are becoming more and more frequent and extreme around the world. We are having frequent, ferocious and devastating forest fires. Tropical storms are now more severe and frequent due to warmer ocean warmths. And if you go to Cochin harbor and talk to the farmers, talk to the fishermen, they will tell you that their catch of fish has been decreasing year by year. Not because there is less fish in the ocean, but because the ocean waters are getting warmer and the fish are moving up north. The fish which used to be caught in Kerala are now caught in Goa or Gujarat. There is less snow in mountain ranges and polar areas, and the snow is melting faster. Siberia, which used to be famous for minus 30, minus 40 degrees centigrade temperature, occasionally has temperatures of plus 30 degrees centigrade. Yeah. Glaciers are melting at faster rates. Major rivers of India and China, Pakistan, they get a large part of their water, those which are perennial rivers, from glaciers. These glaciers go away, there will be severe water shortage, perhaps leading to water wars in these nations. Sea ice in the Arctic Ocean around the North Pole is melting faster with the warmer temperatures. Now, in fact, people are talking about traveling through the Arctic and the sea is not there. Sea ice is not there. Greenland and Antarctica ice is melting too. You can keep reading about it, keep seeing pictures about this all the time. There's something called permafrost. This is when water seeps into ground and then freezes. This makes what is known as permafrost. And this permafrost traps methane. In Canada, Alaska, Siberia, Tibet, etc., this permafrost is melting. And when it melts, it releases methane. This methane is a greenhouse gas. We shall talk about it later. Sea levels are rising everywhere. They are rising just by 0.3 millimeter per year. But year after year, 0.3 millimeter can become very large. Countries like Maldives are just about 1 meter above of the sea level. They will all vanish. They will all drown because of the rising sea levels. I will advise you people to download this report by Intergovernmental Panel of Climate Change. I will say that our report clearly indicates that places where people live and work may cease to exist, that ecosystems and species that we have all grown up and that are central to our culture and inform our languages may disappear. This report, you download and just read it even if you don't follow it, just to understand what are the challenges. All that I'm telling is a very small part of all that is in stores for us if we don't immediately wake up and tackle this climate change. Let Donald Trump tell anything. Floods. You see, what happens is that if the global temperature, if the temperature rises, it leads to two things. One is that there is a lot more evaporation of water, number one, and then hot air can sustain more moisture. So the air gets a lot more water in it, moisture in it. And the moment temperatures cool down in the upper atmosphere, all this water comes down as heavy rain. That is why you are getting sudden, very heavy rains. These this moisture-laden airs lead to what we call rivers in the sky. Droughts and floods or snow are getting much more severe and frequent. They come, either there will be very prolonged drought or there will be sudden flood, which is very severe and is much more frequent. Now this is a very somber picture, not somber, but somber picture. These numbers are in millions. If the global temperature rises 1.5 degrees centigrade, which it has reached now, but whether it will hold or not, that we have to see, then 4,000 million people, which means 400 crore people, will be exposed to heat. More than 300 crore people will not have enough water to drink. There will be risk to power generation. The crop yields will go down completely and habitat degeneration will take place. And suppose this temperature goes up to 3 degrees centigrade, you can see 8,000 million people, 800 crore people will be exposed to very high temperatures. Once the atmospheric temperature, once the temperature is close to 45 degrees centigrade, your air conditioners will not work. You will sweat, but there is so much moisture in the air that because of sweating, your body will not cool. Your heart will have to go on working, will go on continuously working because it does not know anything else. It only knows that it works more, there will be sweating, and then it cools down. It tries that and you will not cool down, and it will lead to heart attacks and all. And you must have read in newspaper reports or even in television how people made huge hangars in Canada and Vancouver to house people during summers in air-conditioned places. Okay. Now, why it is happening? This is the energy consumption in the world from 1950 to something like 2050. This blue part is from oil and biofuels. The greenish part is from natural gas, this cyan color. The black one is from coal. Then this is nuclear energy, hydro, and solar energy. We are somewhere here. And you can see that we are getting most of our energy from fossil fuels, coal and natural gas and oil. This is the world energy share. Coal is 35%, gas is 23%, and these are the ones which do not give greenhouse gases. India is much more. Thermal is 57%, and others are less than that. Okay. Now, what is this story about greenhouse gases? The upper atmosphere of Earth reflects 30% of sunlight back into space. The rest is absorbed by Earth and radiated as infrared. These infrareds, if there are no carbon dioxide and methane and nitrous oxide, these are absorbed by them. Nitrogen and oxygen molecules do not absorb infrared. Only CO2, they absorb but very little actually. To be precise, water and all, they absorb and they send it back, and which heats the earth. Now you may say that, "Arey, to badi gadbad baat hai. These greenhouse gases are very bad." No. In absence of greenhouse gases, there will be no cooling of the earth. There will be no heating of the earth. And if there is no heating at all, in absence of greenhouse gases, the average temperature of Earth will be minus 18 degrees centigrade. There would not have been any life on Earth. Now, here is something of which you should remember it all the time. USA, if you take the historical emission of carbon dioxide, USA is responsible for 25%. USA alone is responsible for 25% of greenhouse gas emissions. European Union, 22%. China, about 13%. Russia, around 7%. Japan, around 4%. India, just about 3%. The rest of the world, 26%. Contribution of India is very little. But India is going to be one of the biggest sufferers of climate change. This please remember. Now, this is the per capita CO2 emissions in tons. Saudi Arabia, 18 tons. 18 tons by weight. Can you switch this off maybe? Yeah. Saudi Arabia, 18 tons. USA, 16 tons. Canada, 15 tons. India, 2 tons. And many African countries will have just about a kilogram or 2. But those are the countries which are going to suffer. Africa, Asia, India, China. This is the annual carbon emission reached 37.2 gigatons or billion tons in 2023. This has reached even higher in 2024 now. How did we, what is it we are talking about? There is a beautiful scientific experiment which was conducted in Antarctica and repeated also in Greenland. What they did was to drill ice from very deep levels. And this is that ice drilled out. As you can see, there are some bubbles in that. There are air bubbles trapped in that. By analyzing those air bubbles, first of all, from the depth, they can know what is the time or period of that air bubble. And then they analyze the air bubble and they can find out what percentage is carbon dioxide, number one. And even more importantly, they can find out the ratio of oxygen 16 and oxygen 18. Now, if they're in the air there, or in the water or whatever, ice. Now, what happens is that if the temperature is higher, then there will be more H2O18. H2O, but oxygen is O18. And if the temperature is lower, then will be less of it. So the oxygen 16 by oxygen 18 ratio is a very good proxy for the temperature. And this has been measured and found that there is a very good correspondence between temperature and carbon dioxide. And this is the history of Earth over 8,000 years, 800,000 years. 800,000 years. And you can see that there is a very complete thing. Most importantly, the amount of carbon dioxide, the blue curve, or the red curve, has never been more than 300 ppm in the last 800,000 years. And now it is something like 424. And if I were your teacher, I would have made your life miserable by asking you to calculate how much is 1 ppm. It will come to about 3 tons or so, 3 gigatons. Yeah? Okay. So this is once again the same graph from 1860 to 2023. Now it is 425 ppm. And 1 ppm carbon dioxide, you can do a simple calculation. Or these days people ask the chat GPT, right, to do the calculations. You can ask. It will be about 2.1 gigatons of carbon or 7.8 gigatons of carbon dioxide. So every 1 ppm counts. Yeah. The sea level rising, I have told already. Now, if all the ice on Greenland melts, It is estimated by some people that sea levels will rise by 20 meters. What is the height of sea level of Cochin? Half of Cochin will go underwater. The sea level rises by 20 meters. Bombay will go underwater. Florida will go underwater. New York will go underwater. Part of, California will go underwater. Of course, Maldives will cease to exist. If all the ice of Antarctica melts, the sea level will rise by 60 meters. Now, you don't even have to stretch your imagination what it will mean. All the coastal areas and island nations will go underwater. So we have to stop this. But we need energy. Either you become Mahatma Gandhi and start living in a corner in a small hut, in a dhoti, a small dhoti, doing nothing. Or you live modern life, which you are living, comfortable life, go around in cars, air-conditioned atmosphere, good education, means of entertainment, high-quality food, protein-rich diet, all these things you need, right? For all that, you will need energy. Now, if you are going to get energy using pulverized coal, this pulverized coal for every gigawatt hour releases 820 tons of carbon dioxide. If you use gas, it is a little less, 460. If you use biomass, it releases 200. People keep talking about biomass as if biomass is panacea. No, biomass releases 230 tons of carbon dioxide per gigawatt hour. But look at nuclear, hydropower, wind, that is just about 12 to 11 gigawatt, 10 to 11 tons per gigawatt hour. So from there to here, it is a big difference. And that is the reason we keep telling that let us concentrate on this. Now if you talk to these climate change people, they will sing praises of solar power. Kochi airport now has solar power. So we are going to talk about coal and oil, biomass and biofuel, hydro, solar, wind, nuclear energy, something which people don't even want to, even the highly educated, very intellectual people of Kerala, I hear, have started talking against nuclear energy, which completely baffles me. But we shall see what happens. And I will also, if I have time, I will introduce hydro. I will go quickly because time is short, and unless you get the whole picture, it is very difficult for me to make my case. Coal mining. It kills more than 15,000 every year. And if you go to coal mines, you will get a chance to go to Bihar or Chhattisgarh. For miles, you will see how coal dust has completely denuded the agricultural area, leaving wounds, and you will smell sulfur. Several thousand are injured every year. Large areas are polluted. And of course, carbon dioxide I have already told. Let us think of one thermal power plant which produces 1300 megawatt. It is one of the same as a large nuclear power. What does it do? A 1300 megawatt thermal power station will need 4.5 million tons of coal every year. You have to have a train loads of coal coming there continuously day and night and burnt. And that 4.5 million tons of coal will release 14.5 million tons of CO2. It will release 1.3 million tons of ash. It will release 650,000 tons of gypsum. These are tons, 1,000 kilograms, right? It will release 27,000 tons of sludge, 38,000 tons of nitrous oxide, 23,000 of sulfur dioxide, 1,300 tons of particulate matter. And because uranium is distributed, it will also release 6.5 tons of uranium into the air. So you can see for yourself what does a thermal power plant do. Okay. There is a technological challenge, and if you can solve this, you will become immortal. That is carbon capture and storage. Of course, methods are available. If you can catch the carbon dioxide which is coming out and store it somewhere from where it remains permanently buried, that will be a solution, but it has to be done. Of course, methods are known, but those are not economically feasible and increase the cost of electricity coming out. You can develop a simpler, cheaper method of doing it. It's called carbon capture and storage. Or you will become immortal, become billionaire also. And there is another thing called carbon sequestration. That is also same thing. That carbon dioxide which is coming out, you can keep it aside, either use it for something or just store it till you find a way. Okay. Oil, you know oil, we keep importing oil, right? Whenever there is oil, you also have oil spills. And this is what happens. When you have a thermal power plant using gas and oil, occasionally you will have acid rain. Now just imagine acid rain over Taj Mahal. I don't have to say anything else. America and Canada, they have become enormously rich by using what is known as shale gas, S-H-A-L-E. This is gas trapped in rocks underground, which was not coming out. So they have developed a technique which is called fracking. What they do is that send in water under very high pressure, mixed with particular gum of beans called cluster beans. I don't know what to call it in Malayalam. In Hindi we used to call it urad bean. So the gum of that, it is also used in ice cream. You mix water with that gum and it makes it thicker, and you send it under high pressure and then you let it bend, and because of this high pressure thing, these rocks crack, releasing oil and gas. And it is this oil and gas, shale gas, which has made America and Canada enormously rich, and the President of USA is telling the whole world, you have to buy our oil, not Russian oil, because they have got a huge amount of storage. Okay? This releases, it contaminates water, destroys this area. Look, this huge area used to be a fantastic forest, and this is what remains of that. Biomass, we keep talking about it, right? Everybody keeps talking about biomass. And you can use biofuel. But it needs to collect waste, compact it, transport it to some place. All these things are very labor intensive and very energy intensive. So it's not very economical. Moreover, when you cut down a tree and burn it, you will get electricity, all right. But the tree stored carbon dioxide for hundreds of years, almost 100 years. And you burn it, and all that carbon dioxide is released within a few minutes. So there will be local peaks, spikes in carbon dioxide. And frankly, when the 1 billion people are still suffering from hunger in the world, I don't consider that it is a good idea to use fields to produce sugar and corn to be converted into oil. That is my personal feeling, others may differ. This you know very well, and what it does. But anyway, biodiesel production is very little, of very small percentage of all that the world needs. Hydroelectric power projects, we keep talking about them. And Kerala has many hydroelectric power projects. Some people are happy, some people are unhappy. India has a generation capacity of 50 gig. The projected capacity is 300 gigawatts, and we have a capacity of only 50 gigawatts. Okay, the other countries. But what is not realized is, what is not told often, is that hydroelectric power, it is resistant, it is affected by droughts, it is affected by seasons, it can lead to dam failures, and it can even cause earthquakes. And it has been estimated that 40 to 80 million people have been displaced in 2000. The Sardar Sarovar Dam displacement is very well known. It causes disruption of wildlife and marine ecosystem and completely disrupts the water flow. Moreover, in dams, there is a silting takes place. After all, water is collected from rundown, and it brings in a lot of soil, mitti, dirt. All that keeps settling in the bottom. And because of that, the level or the capacity of the dam keeps going down year after year. If you ever go to Odisha, there is a Hirakud Dam there. It was a beautiful valley, and one end was, they made a bund at one end and flooded it with water. All those trees are submerged there. All those trees are rotting there. All those trees are releasing methane slowly, slowly. Nothing can live in that poisonous water. Moreover, from top of the dams, enormous amount of water is evaporated away. The evaporation of water can be as high as 5,000 to 70,000 liters per megawatt hour. It is not a small amount. But what does this do? The water evaporates away, but any water has some salt in it. So the remaining water in the dam is getting more and more saline. The Sumerian civilization, one of the greatest early civilizations, which discovered agriculture and monoculture, died because of silting, and salinity, increase of salinity in their water. Let's come to sun. Sun is a wonderful thing. It releases about 3.8 into 10 to the power 26 watts of power. And it will go on doing it for 5 billion years at this rate. And it happens because it converts 4.3 million tons of matter to energy per second, E equal to mc square. We'll give you that number. From 4p going to helium-4. If you look at the spectrum of sun, measure it at the top of atmosphere, it corresponds to a black body radiation of about 5250 degrees centigrade. But if you measure it at sea level, it is this red curve. So water vapors, carbon dioxide, H2O, they all absorb a lot of it. And on sea level, it reaches only 1,000 watts per square meter. Sunlight, morning, noon, evening, ideally. No sun, no sunrise, no sunlight. No sunlight, no electricity. So all those who talk of sunlight, solar power, ask them, will they be happy getting electricity only during the day? And then you can have overcast skies or rainy days. In Calcutta, we used to have rains continuously for 7-8 days, and we would not see the sun. Okay? There is a particular festival where the women have to see the sun, and the sun does not rise for days. However, if you could cover just this black dot area with solar panels, the energy produced can meet the entire energy requirement of the world, because that will be about 18 terawatt electrical, which is the current requirement of the world. There is some solar panel, and solar panels have been increased considerably. By 2030, it will go to about 11,000 gigawatts in the world. Already it is 2,900 gigawatts. Something is there. Yeah, okay. So intermittency I have already told because of clouds. You take just 4 grams of dust and you spread it over 1 square meter. Very little. 4 grams is very little, no? Chutki bhar sandoor or chutki bhar dust, right? You just spread it over solar panel. Its efficiency will go down by 40%. That means that if you have solar panel, you have to wash it all the time. Pani kahan se milega? Where will you get that much water from? Okay? You need 5 acres of land to produce 1 megawatt of power, and I will come back to you. The efficiency of solar panels goes down by 1% every year. So in a few years, it will become useless. After 7, 8 years, 10 years, China will sell you by telling that it will last for 25 years. If it sells it to USA, it will last for 25 years. If it sells it to India, it will last for 7 years. Okay? So after that, what will you do? It is estimated that millions of tons of solar panels, actually 70 million tons of solar panels every year across the world will be generated as a waste. We have to immediately figure out a way. If somebody wants to start a startup, start on that. Yeah. And it has toxic materials like lead and cadmium which are released in water. You will need battery. If you want to use solar panels, you need to have batteries. Free mein nahi aati hain. Batteries are also expensive. Batteries are also have to be, there are other methods called pumped hydro, heat, compressed air, green hydrogen. I will come to that. Solar panels and batteries use rare materials or rare earths. These are mostly found in some countries like China, in Afghanistan where it is very difficult to, in Argentina, Bolivia. These are not uniformly distributed. Any source of metal or energy which is not uniformly distributed will be exploited by those nations. Like Gulf nations used their availability of petrol to their advantage, right? Like that. Local weather is affected. Now people have started telling that the solar power panels which are installed in large areas, they are affecting local weather. It has to be studied. It has not been seen what is its effect on the ground. Another problem. All of you are using mobile phones, including me. All these mobile phones use cobalt. Where does cobalt come from? Most of it comes from Congo. And these 4-year-old, 5-year-old kids are made to work in those mines. Remember that any time when you are gasping on your mobile phone. There is a concept called concentrated solar panels where you can have lots of mirrors which can reflect the sun rays on a receiver, which can then heat something, oil or so. It was made in Morocco, 500 megawatt, but for some reason it is not working. Actually, I have not even been able to understand why it is not working. But the problem is that mirrors need to be cleaned. Where do you get maximum sunlight? In deserts. Do you have water in deserts? No, because there is no water, there are deserts. So they also break easily, unless you want to make them very thick. With slightest wind, they break. So thousands, and one such thing was abandoned in California long ago. Wind energy, very nice, one of the cleanest renewable sources of energy, because there is no greenhouse emission, only occasional maintenance is needed. But, and it is also being used, expanding rapidly, but what is not told is that wind in most of the places is very intermittent. Only in offshore areas of some places like northern seas, in England or Scotland, do you need something where it is continuously there. You need 20 acres per megawatt, 20 acres of land, because you cannot put, solar panels can put side by side. Windmills have to be, you have to keep distance between them. Because windmill, even mathematically can stop only half of the wind. So after wind has passed through windmill, the rest of the wind will be at less speed. So you have to see that windmills do not cast shadow. So they have to be kept separately, right? These are limited to hilly terrains, ridges, offshore, local warming they cause. They are killing birds, bats, and they cast flickering shadows, because of which animals and also people who have epilepsy suffer quite a lot. Installation can be very expensive, because now windmills which have a span of 50 to 200 meters are coming up. These are several thousand tons. How will you take it? Or ordinary roads, even of good roads of Cochin, will not be able to carry a truck which is carrying a load of several thousand tons. And these have to be transported into the sea or on hills. The road construction itself will become very expensive. Look, baat nahi karte. People will not tell you all these things. They are trying to sell all these things. So all the problem is that every day I read newspaper, I read articles written about solar panels, about wind energy and all. None of them about nuclear energy. None of them are by scientists. They are all by what you call influencers. People who are paid to write good things about their companies. So it is very important for you to read genuine material written by scientists. Okay. And of course you will need batteries. Batteries, I have already told you that 87% of lithium comes from Bolivia, Argentina, and Chile, where extraction is devastating the environment and freshwater sources. Okay. I mean, I'll leave the slides here, you can check them again. Now let me come to nuclear energy, because here I want to spend a little more time. And I would like, please, if you have any doubt, ask it now. As in Christian marriage, at the time, in Kerala, you have lots of Christians, so you know. At the time of marriage, the priest says that this man and this woman wants to get married. If anybody has any objection, please come forward now or keep your mouth shut afterwards. So similarly, I'm going to talk about nuclear energy. If you have any objection, please tell it now. Otherwise, I will assume that you have no objection. Yes. Huh? Yeah. Yes, both ways. Yeah, and this is not all is bad. Dams have converted Gujarat, right, into a, Rajasthan has been converted. But you should also be aware of what problems they lead to. That's all. I'm not saying that dams will convert all the Tibet region, all the Chinese region, where nothing has grown for thousands of years. Those will all become very productive areas, but they will also cause a lot of devastation. Okay. Consider this nuclear fission. Nuclear physics is being taught to you, I understand. Uranium-235 undergoes fission because of thermal neutron, and the energy release is 200 MeV. Consider burning of coal. One reaction, the energy release is 4 electron volt. So every reaction, nuclear fission is releasing 50 million times more energy. Nuclear fission releases 50 million times more energy per fission, per reaction. That itself should tell you how much more profitable and powerful is nuclear energy. Okay. And then if after one fission, there may be 2 to 3 neutrons produced, those can be absorbed by other uranium-235, which can undergo fission, and then undergo fission, and like that, and you can have a chain reaction. But there is a problem. I'm talking about uranium-235. Now, uranium-235 is the only naturally occurring isotope which undergoes fission because of thermal neutron. And this isotope is only 0.7% of the total uranium which is obtained. Okay? Uranium-238 does not undergo fission with thermal neutrons. Undergoes, but both come. Okay? So you have two possibilities. Either you enrich it and then use it without water. Moreover, this neutron which comes out after fission, they have a high energy. They are not thermal. Their energy has to be released before they are absorbed. That is done by moderators. For moderating, you can either use water, this water, or heavy water called D2O, where hydrogen is replaced by deuteron. Deuteron does not absorb neutrons, proton absorbs neutron. So if you use ordinary water, many of the neutrons will be absorbed. And therefore you have to enrich the uranium in order for this process to continue. Or you can use heavy water, then you don't need to enrich uranium. I have already told you that nuclear energy is very dense. This is just one pellet of nuclear fuel. This is equivalent to 1 ton of coal. 1 ton means 1,000 kilogram. 500 cubic meters of natural gas or 500 liters of oil. Right? Nuclear power is generated Even when the sun does not shine or the wind does not come rain, come storm, come snow, nuclear energy stays on, while renewable just भाग जाते हैं. Some years ago in Texas there was a severe storm. Texas, full of oil. All their thermal power plants stopped. Nuclear plants kept going and kept them alive. Number of operational nuclear reactors by country: USA 96, UK 15, Ukraine 15, India 23. These numbers will change. Nuclear share: France 70%. By having it 70%, by meeting 70% of their energy demand, France completely shielded its economy for decades from the price increases of petrol. Since the 1965 Arab-Israel war, when prices started going up, other countries suffered. Okay? So the energy supplied last year during 2020 was 2.5 million gigawatt hours, about 10% of the total, and which averted release of 2 million metric tons of carbon dioxide during the year. This is the world energy production by the year. This is number of nuclear reactors on the way. In 2021, it is a little better now. Most of them are being made in India and China. And then Kerala is rich with thorium, monazite sands, and that can power nuclear reactors for hundreds of years. Now, this is something which people don't talk about. Let us consider, and it all has its origin in that fifth factor of 50 million, which I told you about. If you want to produce 1 terawatt hour of power using solar, what you will need? You will need so much, 4,000 tons of steel, 750 tons of concrete, 7,900 tons of, that was cement. This is steel. This is glass and other materials. In hydro, you will need 14,000 tons of concrete. In wind, you will just need 800 tons of concrete and all. Solar, nuclear, this little. This picture, none of the solar fellows will tell you. None of the wind fellows will tell you. And the nuclear fellows are already made apologetic. They are made to feel apologetic by someone called SP Uday Kumar. So they don't even talk about it. There's another thing which is not realized, which should be remembered, all of you. It is your future. We are on our way out. 10, 20 years, at most 10 years. If I live for 10 more years, I will be very happy. We are gone. This world is for you. Do remember that all these power plants have a capacity. Capacity factor means if you say that this plant has a capacity of 1000 megawatt, it will give you on an average 200, taken average, it will give you 250 megawatt. So when somebody says that solar panelists, they have installed 4,000 megawatts of solar plant, remember, power आपको 1000 megawatt मिलेगी. Same thing with wind, 35%, hydropower, 40%, coal, 50%, natural gas, 56%, nuclear, 93.5%. If a nuclear fellow says that he is installing 1,000 megawatt nuclear power, he will give you on an average 935 megawatts. That capacity factor itself. So people are telling numbers without all these all these complications. Okay? Then you are all nuclear physicists. Some of you are definitely. There is a new thing on the horizon which has been going on for quite some time. It may take some time, but it will find a solution, that is fusion energy. Using deuterium tritium fusion to produce neutrons and unlimited source of energy, and the tritium can be generated by the action of fast neutrons on lithium-7. That's it. ITER, India has contributed 30,000 crores to it, and it is under construction in France. It is a demonstration one, but people are very confident that it will work in spite of difficulties. And maybe 50 years' time, in your lifetime, it is very definite that fusion energy will be available. Then no chinta onwards. This is a beautiful concept, and therefore I want to talk about it, a pumped up electricity. During the day, the sunlight is very strong, right? So you can produce a lot of extra power, which you don't need. But you can use that power to pump water to a higher level. And when the sun is not shining, let that water flow down, produce electricity. And that is a beautiful concept. But lafda hai. Lafda kya hai ki I had not seen a hill in my life till I went to Bombay from Allahabad in 1970. Large plains of North India have no hills. There is no way for you to generate something like this. Yes, you can replace water with something like steel or stone, and you can raise it to a higher level using crane or something, and then bring it down to produce. But that is not same as pumped up hydro, right? Quickly I will go through hydrogen, because this is a beautiful concept, but a concept. Because hydrogen you burn, what you get? Water. If you can burn hydrogen, you can use hydrogen, absolutely fine. But hydrogen is not found in nature. You have to produce it. You can produce it by gasification of coal, but you produce 16.5 kilogram of carbon dioxide for 1 kilogram of hydrogen. And therefore it is called black hydrogen. You can produce city gas, or it is called city gas, which is essentially methane, and you will need 5.5 kilograms of carbon dioxide for 1 kilogram of hydrogen. So hydrogen production from these methods using coal and gas releases a lot of carbon dioxide. You can have blue hydrogen where you use coal and gas to produce electricity, but you can, if you can capture all the carbon dioxide and store it somewhere. This is called blue hydrogen. इसमें नहीं निकलेगा. There is a new concept called turquoise hydrogen, where methane is passed over some material which is not known, because that is they have copyrighted it and they don't tell, and it produces pure carbon and hydrogen gas. That carbon, pure carbon, can be very useful, like this. You can have paints, you can make bricks, you can make polymers, etc. You can have green hydrogen if you can get the electricity from solar panels and then use that electricity to have an electrolysis of water. Then you can produce hydrogen, and that is called green hydrogen. But electrolyzers use platinum on their, most of them use platinum on these cathodes. Kahan hai platinum? Only one small country, South Africa, and some areas of Soviet Union, former Soviet Union. We need very good hydrolysis plants. Then we can produce good hydrolysis plants cheaply. We can produce hydrogen cheaply, and that is future.
There is another thing called pink hydrogen. You can have very high temperature nuclear power reactor, and you can have a reaction, cyclic reaction in which hydrogen is produced. So, the sun is always shining, remember. Sun is always shining somewhere or other. When the sun is shining now here, in Australia where my daughter lives, the sun has already set. The sun will be, would have set here in another 2-3 hours, but it would still be shining in England where our sun lives. So sun is always shining in half of the world. If we can connect, if you can have solar panels all over the world and connect them through a grid, which is called International Solar Grid, which Government of India is suggested, then you can have beautiful power all the time. So you can connect, you can have international grid with hydroelectric power dams, nuclear power plants. You see, because of the intermittency of renewable energy sources, you have a serious problem. People don't tell you that the production is fluctuating like hell. The management of grid will need enormous capabilities of AI to handle this. But using AI, you can also predict how much solar power is going to be generated from which area. And then you can have a grid management. It is not going to be easy. It is going to be very effective, but it is going to be useful. It has been estimated that if you have about 30% of the power coming from nuclear energy and rest from renewable, we can still handle it. But in future, we need to produce the entire solar energy and renewables. Even if we tap, we will meet only 60% of India's requirement, energy requirement by 2050. So you will have to produce lot more energy than from using nuclear sources than we have planned now. Okay. So, that I have already told, we need to be more efficient solar panels, which can take low energy photons, combine them, and make a higher energy photon to ionize, and use higher energy photons to cause multiple ionizations, also cheaper and more durable ones. So let us make an international grid and provide sustainable, clean, green, and reliable power to all. One sun, one world, one grid, our International Solar Alliance of 140 countries, which Government of India has proposed. So looking ahead, the only way this monstrosity of climate change can be handled is by having international collaboration to accelerate development of more efficient solar cells and storage and turbines, a very efficient worldwide web of electricity, fast breeder reactor technology, molten salt reactors, small modular reactors. And there is, I did not tell you about accelerators of driven subcritical systems and fusion, and international autonomous body for research and regulation of nuclear safety. Our Earth, because of heating, has reached somewhere here. If we don't tackle climate change and global warming, we'll go here and get into a hothouse Earth. And the temperatures will be 50 to 60 degrees centigrade, enormous humidity, and complete hell. But if we can still work and save ourselves, then we can stabilize it. So life of future generations are in your hands, not our hands. We are gone. We have created a problem for you. Your parents, people like us, have created a problem for you. Your lives are in your hands. Your efforts today will ensure a safer, healthier world for future generations, a world where children thrive in harmony with nature. Many of these things are discussed in our books. in great detail, which I and Professor B.S. Ramamurthy, who used to be Secretary Department of Science and Technology, wrote, and also this one, where these things are discussed. Thank you. How much overtime? Not much. Huh? Okay, good. Now start throwing all your big bats. Thank you, sir. See you again sometime. Sure, sir. Not much.
Can you give some numbers?
I have it, but not on this slide, otherwise I would have shown. The book contains that number. I'm sorry, I don't remember
So
it.
if we go
But
for a
you see, now that we can buy uranium from anywhere, let us use that and keep our uranium sources. But recently some other sources of uranium have been found, which if exploited, it will be valuable. But we have only about 100, 200 years of uranium. India is not very rich in uranium. Australia is, Kazakhstan is, Russia is, China is. Yeah.
see, these nuclear reactors produce some radioactive waste, right? What do you actually do with that?
I knew it was coming, and I'm ready for it. You see, it is not waste. Department of Atomic Energy considers this as nuclear asset. I don't know whether I have it on this. There is a separate talk which I talk about, where I talk of nuclear waste and nuclear energy and nuclear safety. A large part of that waste are actinides like plutonium and other minor actinides, which are actually fuel. So America has taken a view, and if Americans start wearing a torn jeans, all our boys and girls start wearing torn jeans. Everybody follows it, right? So America has taken a view that nuclear waste or the spent fuel should be just stored because it will keep it safe from terrorists. We don't have that view. We can separate plutonium and other actinides from there and use it back as a fuel, which we are doing. It still has some isotopes left. It is the plutonium and other minor actinides which have long lifetime. The remaining part, which is a small part, just about 2% or so, is nuclear isotopes which are not that long-lived, like cesium-100. It can be used in place of cobalt-60, which used to be produced in nuclear reactors. So this is not a waste. Nuclear, India uses it, recycles its waste, call it, spent fuel. I will not call it waste, the spent fuel. It recycles it and uses it back in reactor. China does it, France does it. America does not do it and encourages others not to do it, making them dependent on their American, Canadian, Australian, Chinese, Russian uranium. We have less uranium, so let us use it. Why should we waste through it?
Where is it stored in India? Is there a storage place in India for a...
No, there is no need to store. I mean, right now they have stored some, but those are stored in, if I remember correctly, in water tanks. But those are all ready for recycling. Yes,
I have one more question. See, if you were telling that nuclear energy is actually cheap. If it is so cheap, why I expect a lot of private companies to start nuclear power stations. For example, in the field of
wind energy, etc., a lot of private players are doing business. Why no big Indian private companies are coming forward to establish nuclear power
First of
stations?
all, Indian private, that's very nice question and very timely question. First of all, only now Indian companies were not coming forward in the past. Now that they know that American companies like Google and others have started going for Google and Tesla and what this fellow Microsoft, they are going for nuclear energy, that they have come forward. So our Indian industrials lack originality. They copy. First thing. Second thing is that they need power. Nuclear energy plant, I did not tell. I told you that nuclear plants, once built, will last you 60 years to 70 years. And after that, a little earlier perhaps, you can do a refitting and their life can be increased to 100 years. Solar panels will last you 5 to 7 years. The windmills will last you 10 to 20 years. So here you have a very assured supply of energy, and that is why they are coming forward. Of course, now they know that our own engineers can make nuclear reactors and run them very safely for years and years. Their designs are safe, and therefore they are coming forward. And the NPCIL is supposed to raise money from the public. Quite some time ago, Government of India took a decision that it should raise money from public. So that is one reason why private companies are coming forward. But as far as I know, so far the idea is that the private companies will provide money, NPCIL will build it and run it. I don't know whether there will be some relaxation in that process or not. But anyway, everything has to be made by private industry. But what is more important is that if we can have modularization of reactors, if you can produce same reactors again and again, standard design, like in car, you produce 1 million cars a day. Of course, you will not need produce 1 million reactors a day, but if you have a standard design, you can produce them, and then it will become much cheaper and cheaper.
Any other question?
I had a information that someone asked how many of you are opposed to nuclear energy, and it turned out that more than 60% were opposed to nuclear energy. And I told that despite that I'll give this talk, and I was prepared to face the brickbats. Where are the brickbats? Don't get scared of me. I'm not going to be your examiner. I'm not going to give you marks in your examination. I'm not going to sit in any examination board. So you can ask questions. If you don't like, we will see. Yeah.
Any other questions?
Yes.
Hello, sir.
Yes.
Thank you for an excellent lecture.
Thank you.
I actually have 2 questions regarding your lecture. One is, could you talk some more about the thorium-based nuclear reactors? And the second one is that most of the modern thermonuclear weapons are based on fusion reaction initiated by a fission core. So can those principles be replicated and used in a nuclear reactor?
Second question, let me first answer the first question. Second question I did not fully hear, so I will ask you again on that. That's a very nice question about thorium. You see, thorium is not a fissile material, which means that it does not undergo fission, but it is fertile material. In that, it can absorb a neutron and that get converted into uranium-233. like uranium-238 is a fertile material. It absorbs neutron and slowly gets converted into plutonium-239, which can be used in the reactor. And plutonium reactor, one plutonium it is called fast reactor because if you use plutonium, you don't need moderator, and you can use fast neutrons themselves to have the nuclear reaction. One fast reactor of 40 megawatt has been operating in Kalpakkam, not very far away from here, for more than 40 years. And the second one is FBTR, fast breeder test reactor, is under construction and fuel loading is going on. But these will have lot of neutrons coming out. Fast breeder reactors have this advantage that they produce more plutonium than they use. They produce more fuel than they use. So the reactor is surrounded by either thorium or uranium-238, which is converted into fuel. And that is how thorium is going to be used.
Okay, thank you, sir.
But there is an entirely new concept called advanced heavy water reactor or molten salt reactor, in which you use thorium fluoride or thorium chloride, I forget, in a molten form. And it keeps circulating, getting converted uranium-233 and undergoing fission. So you can use thorium directly.
Thank you, sir.
Yeah.
I'll repeat the second question.
Yeah.
So, I have heard the modern fifth generation nuclear weapons use fission-powered fusion. So the first stage is fission, and it actually powers the thermonuclear fusion, and the weapons work by that principle.
Yes.
Are you aware of any reactors working by that principle?
No, I'm not aware of in great detail, but I do know that in Los Alamos they have been working on laser ignition, and they sometimes news keeps leaking out that they have succeeded in it, that they can ignite it using lasers. So if you have many laser beams concentrating onto one point, you can have a very high temperature, which can then initiate the reaction, which can cause the fusion. Or you can also have what is known as is another process in which you heat it, lots of X-rays are produced, which then are concentrated onto another point where the high temperature is produced. And deuterium, tritium pellets can be shot at each other at very high energy to cause what is known as inertial fusion. So those concepts are since these are weapon issues, only occasionally we read something about it. But I know that, I know for sure that Los Alamos and Lawrence Livermore National Lab people are working on it. Yeah. And by the way, lot of uranium was available in fission bombs. And once the people decided to go down on bombs, that uranium was enriched uranium, so now that is being diluted and being sold as nuclear fuel. Because for nuclear weapons you need 80 to 90% enriched uranium, whereas for nuclear reactors you need 5% enriched uranium. So that uranium bombs are being converted into nuclear fuel. Yeah.
Any questions?
Nobody talks about radiation being very dangerous. Very nice. It means they are convinced that nuclear radiation is not dangerous.
If there is no more questions, let us thank Professor D.K. Srivastava for this wonderful talk. So I hope his talk, it helps to remove some misunderstanding related to this area. Thank you very much.
Excuse me, can you